And here is a solution to the problem posted on the thumbnail. So S is a set of all functions from R to R such that f is a polynomial and f of x equals fx to the power 2024 for all x belonging to real number. We need to find the cardinality of the set S. It means number of such functions. Now clearly the most general way to do this polynomial kind of problem is to match the degree of polynomial. So let's start with the general polynomial a0 to an x to the power n. Of course coefficients are also real for this polynomial. Okay, so that they have mentioned in the problem. So if you'll see f of x, so basically instead of x I'll replace this x with f of x. So we'll have a1 fx and an fx to the power n. If we'll plug all this value, the highest degree of term that you are going to get will be from the last term, right? Because a0 till an xn to the power n, which means the maximum power which I'm going to produce is n square. Okay, so this expression will be something a0 plus something x plus something x square and so on till the highest ordered term will be x to the power n square. Now what about fx to the power 2024? Again, now in this entire f of x, if I'll put 2024, again the highest order will come when this box will get multiplied with 2024 times. So let's say you have chunk of a0 and kind of an xn, and if you are multiplying this kind of a structure 2024 times, the maximum occurred term is this, right? This is the most powerful term. So when all these terms will collide among themselves, okay, so that will give birth to an to the power n and xn to the power 2024, n to the power 2024 and xn to the power 2024. That's what I have written over here. So the maximum power term that we will get from here is x to the power 2024 n. So now degree of LHS is nothing but n square and degree of RHS is nothing but 2024 n. And that's a clue, because if this polynomial has to be true for x belonging to R, their degree must match, right? So that gives me 2024n must be equal to n square. And that gives two solutions, n equals 0 or n is 2024 to constant polynomial. Okay. So either polynomial is constant or polynomial is up to degree of 2024. It means it's a0 a1x till a 2024 x to the power 2024. I hope it's clear till here. Now if p of x is constant, if we'll plug back in the original expression, you can clearly see we'll get f of x is some constant, let's say a0. So what about f of x? So it's f of a0, and f of a0 is again a0 because it's a constant function. So LHS becomes a0, RHS becomes a0 to the power 2024, and that gives two value. A0 is either 0 or 1. So we have got already two functions, f of x equals 0 and f of x equals 1. We are left with one more solution, right? The solution when px is this. So what about p of x? Oh. And this will be 1 p of x to the power 2024. Now p of x is simply a0 plus, in a1 you can replace with px and so on and so forth. So a 2024 p of x to the power 2024, and that's gonna give me a0 plus blah blah a 2024 to the power a 2020 to the power 2024. Now we'll see the basic idea. This is nothing but px to the power 2024. Now if this has to be true for all x, right? Because if you see the LHS, what we are having, we have a0, a1 p of x, and so on and so forth, a 2024 p of x to the power 2024. And RHS is just px to the power 2024. So under what condition this is possible? If it is true for all x belonging to real number, it's definitely possible because RHS is not having any other term. Right? RHS is not having any other term. One way of visualizing this is you can even write, like p of x as the original expression. So you'll get a1 times a0 plus a1x and so on and so forth. Again, you write a2 times a0 plus a1x whole square and so on. And then last we'll have px to the power 2024. And the last of the LHS is a 2024 px to the power 2024. Now if you equate all the values of, because the constant term here is going to be a0 to the power 2024 Okay, and constant term from here will be a0 to the power 24, a1 a0, and so on and so forth. And from last we have a0 to the power 24. Okay, so clearly you can see here, if I can take a0 common, I'll get something equals 0. So one of the solution is a0 equals 0. Okay, similarly you can prove a1 a2 everything will die just by equating. Okay, because that you can see the inertia of the problem. Moreover, in other way you can tell, since this expression equals that, and so in LHS a 2024 must be 1 and p of x 2024 must match. It means these coefficient must be 0. Now this you cannot tell directly. Why? Because in a very constitutional way this is not true. If I ask you if 2 plus root 3 is a plus b root 3, can we just tell a equals 2 and b is 1? This is not true if a b is a real number. Okay, because I can put even a to be 19 and then b will come out as something. But if ab becomes rational number or ab becomes integer, then in that case you can tell. Okay, so since x is dependent, so directly concluding like RHS must be this and all term will be 0 will be not mathematically correct statement until you prove it. But from other logic, if you equate, you'll get a0 0, a1 0, and so on by equating. That we can feel very easily, because every times a1 a0 will be coming common from the equating coefficient of x square. So that's very interesting. So finally every expression is 0 except a 2024. So what we are getting, an is 0 for any n less than or equal to 2023, and that become 1 for n equals 2024. So that makes your polynomial p of x as x to the power 2024, and indeed it works, right? Because it's whole square, x to the power 2024 whole square is same as you replace x to the power 2024 to the power 2024. Okay, so the final solution of this problem is S is the set of three expressions, 1 0, which is 2 constant, and x to the power 2024. Hence the cardinality of set S is